Assalamu alaikum. This is MD Sadman Siam. Welcome to our presentation. I am doing my BSc in Computer Science and Engineering. My ID is 2321538 This presentation presented to Mr. Saurabh Poddar, lecturer, Computer Science and Engineering, Daffodil International University. Today, me, MD Sadman Siam, 2321538 and my teammate Shopon Roy, Yasin Sajjad Pial, Mahfuz Ahmed Hanif, Sagar Das are going to represent about optics, which is the part of physics course. Area covered: concept of historical background of optics, theoretical background of optics, four theories of light, reflection, refraction, total internal reflection, critical angle. Introduction. Optics, a physics branch, explores light's properties, interaction with matter, and instrument construction for its use or detection. It encompasses visible, ultraviolet, and infrared lights behavior extending to electromagnetic waves like X-ray and radio waves due to their analogous properties. Concept of historical background of optics. Optics began with the development of lenses by the ancient Gypetans and Mesopotamians, followed by the theories on light and vision developed by ancient Greek philosophers and the development of geometrical optics in the Greco-Roman world. Optics was significantly reformed by the developments in the medieval Islamic world, such as the beginning of physical and physiological optics and the significant advances in early modern Europe, where diffractive optics began. Now my other teammate explain rest of the topic. Thank you, sir. Assalamu alaikum.
Hello everyone, I am Sagar Das. My ID is 232159294. Welcome to our presentation. Theoretical background of optics. The theoretical understanding of light has evolved over centuries with various theories proposed to explain its nature. Here are four key rules of light. Newton's corpuscular theory of light. Newton's corpuscular theory of light is based on the following points. Point 1. Light consists of very tiny particles known as corpuscular. Point 2. These corpuscles on emission from the source of light travel in a straight line with high velocity. Point 3. When these particles enter the eyes, they produce image of object or sensation of vision. Point 4. Corpuscles of different colors have different sizes. Next. Huygens wave theory of light. Christian Huygens proposed to the wave theory of light according to Huygens wave theory. Point number 1. This point in a source of light sends out waves in all directions in hypothetical medium called ether. Point 2. Light is a form of energy. Point 3. Light travels in the form of waves. Point 4. A medium is necessary for the propagation of waves and the whole space is filled with an imaginary medium called ether. Point 5. Light waves have very short wavelength. Our next member will present next slide. Thank you.
Hello everyone, I am Shupon Roy. My ID is 232155716. Thank you my previous participants for explaining the presentation. Now I will continue the presentation. Now my part is quantum theory of light. It is one of the four theories of light. So let's discuss. It was put and forwarded by Max Planck in 1905. According to quantum theory, energy radiated or absorbed can't have any fractional value. This energy must be an integral multiple of a fixed quantity of energy. This quantity is called quantum. Now, let's talk about electromagnetic theory. This theory was given by James Clerk Maxwell, and the key idea of this theory is light is an electromagnetic wave. Maxwell equations formulated in the mid-19th century showed that varying electronic and magnetic fields could propagate through space and as a self-sustaining wave. The significance of this Maxwell's electromagnetic theory of light successfully unified electricity and magnetism and predicted the existence of electromagnetic waves, including light. This theory laid the foundation for understanding light and as a part of the electromagnetic spectrum. Thank you.
Hello everyone, my name is Yasin Sajjad PL. My ID is 232151102. Now I am telling about reflection of light. When a ray of light approaches a smooth polished surface and the light ray bounces back, it is called the reflection of light. The incident light ray that lands on the surface is reflected off the surface. The ray that bounces back is called the reflected ray. It is perpendicular where drawn on a reflecting surface. It would be called normal. The figure below shows the reflection of an incident beam on a plane mirror. Here the angle of incident and incident of reflection are with respect to normal and the reflection surface. The law of reflection. The law of reflection determines the reflection of incident light rays on reflecting surfaces like mirrors, smooth metal surfaces, and clean water. Let's consider a plane mirror as shown in the figure above. The law of reflection states that the incident ray, the reflected ray, and the normal all lie in the same plane. The angle of incident equal to angle of reflection. Now I am showing you a reflection of light. Reflection of light, one of the most commonly observed phenomena. But other waves like sound waves and water waves also experience reflection. Refraction makes it possible for us to have optical instruments such as magnifying glasses, lenses, and prisms. It is also become of the refraction of light that we are able to focus light on our retina. The law of refraction of light. Law of refraction states that the incident ray, refracted ray, and the normal to the interface of two media at the point of incident all the lie on the same plane. The ratio of the sine of the angle of incident to the sine of the angle of refraction is constant. This is also known as Snell's law of refraction. Here is the equation. And thank you, my topic is end here. Now the next topic explain my next presenter.
Hello everyone, I am Mahfuz Ahmed Hanif. My ID is 232154465. Now I am talking about the total internal reflection. The total internal reflection is defined as the phenomenon which occurs when the light ray travels from a more optical denser medium to a less optical denser medium. Consider the following situation. A ray of light passes from a medium of water to that of air. Light ray will be refracted at the junction separating the two media. Since it passes from a medium of a higher refracted index to that having a lower refractive index, the reflected light ray bends away from the normal. At a specific angle of incidence, the incident ray of light refracted in such a way that is passed along the surface of the water. The particular angle of incidence is called the critical angle. Here the angle of refraction is 90 degree. When the angle of incidence is greater than the critical angle, the incident ray is refracted back to the medium. We call this phenomenon total internal reflection. Now I am talking about the critical angle. The critical angle is the angle of incidence to which the angle of refraction is equivalent to 90 degree. When light enters a denser media from such a comparable rare medium, the orientation of light changes as well as the light beams bending toward the normal. Absolute internal reflection is the complete reflection of such a light beam of the surrounding medium directly into the fluid medium as well as glasses. This only happens whenever a light beam would be in a dense medium as well as approaches a much less dense media whenever the light rays angle of incidence is larger than the critical angle. That's all of our presentation. Thank you for watching our presentation. Allah Hafiz.